Welcome to Tech Lab by Sid. What are microservices? Microservices is an architectural style for developing software applications as a collection of loosely coupled, independently deployable services. Each service corresponds to a specific business functionality or domain and is designed to be small, self-contained, and responsible for a single task or a set of related tasks. Key characteristics of microservices. Independence. Each microservice can be developed, deployed, and scaled independently. This allows for a more flexible and agile development process, as different teams can work on different services simultaneously without stepping on each other's toes. Decomposition. Microservices break down a complex, monolithic application into smaller, manageable services. Each microservice is focused on a single business capability, example, user management, payment processing, order fulfillment. Loose coupling. Microservices interact with each other through well-defined API, often over HTTP or REST or message queues. Because of this, the services are loosely coupled. Changes in one microservice should not affect others, provided the API contract remains the same. Technology agnosticism. Each microservice can be built using different programming languages, databases, or frameworks, as long as it adheres to the same communication protocol. This allows teams to choose the best tools for the task. Scalability. Since microservices are independent units, individual services can be scaled independently based on demand. For example, if the user authentication service is under heavy load, it can be scaled without affecting other parts of the system. Resilience. If one microservice fails, it doesn't necessarily take down the entire system. The failure of a single microservice can be handled with retries, fallbacks, or circuit breakers, so the application can still function partially. Autonomous teams. Microservices are often developed by small, cross-functional teams that own the full lifecycle of a service from design and development to deployment and maintenance. Benefits of microservices. Faster development and deployment. Teams can work in parallel on different services, which speeds up the development process. Additionally, because services are small and independent, they can be deployed independently, allowing for faster release cycles. Scalability. Microservices allow horizontal scaling or scaling out at the service level. For example, if one part of the application experiences heavy traffic, only that service needs to be scaled, not the entire application. Resilience and fault tolerance. Since services are decoupled, a failure in one service is less likely to affect others. This makes microservices more fault-tolerant and resilient. Flexibility in technology stack. Developers can use the best tool for each service, making it easier to integrate with new technologies or adopt changes in the tech stack without reworking the entire application. Easier maintenance and upgrades. Microservices are easier to maintain because they are smaller and more focused. Upgrading or fixing a bug in one microservice does not require changes to the entire system. Challenges of microservices. Complexity in management. While each service is simpler, managing many microservices can be complex. This includes challenges around deployment, monitoring, logging, and communication between services. Network latency. Since microservices often communicate over a network, example, through a REST or message queues, there can be additional latency compared to in-memory calls within a monolithic application. Data management. Microservices typically have their own databases, which can lead to data consistency issues. Managing distributed data across multiple services can be tricky, and techniques like eventual consistency or distributed transactions may be needed. Deployment overhead. The need to deploy and manage many small services can increase operational overhead. Tools like Kubernetes, Docker, and service meshes, example, Istio, are often used to manage this complexity. Testing. Testing microservices can be more challenging, especially when testing the interactions between services. End-to-end testing needs to account for all possible combinations of services. Microservices versus monolithic architecture. Monolithic. In a monolithic application, all the components, for example, user interface, business logic, database interaction, are tightly coupled and run as a single unit. Scaling and deploying updates can be more difficult because everything is interconnected. Microservices. In contrast, a microservices architecture decomposes the application into small, independent services that can be developed, deployed, and scaled independently. This offers greater flexibility, but introduces challenges in management, communication, and data consistency. Use cases for microservices. Large applications. Microservices are ideal for large-scale applications with complex functionality, especially when the application needs to scale quickly or evolve with different teams working on different components. Cloud-native applications. Microservices fit well with cloud environments, example, AWS, Azure, Google Cloud, as the cloud's scalability and distributed nature align well with microservice principles. Continuous delivery and DevOps. Organizations practicing DevOps or continuous integration or continuous delivery, CI or CD, benefit from microservices because they allow frequent, independent deployments with reduced risk. To summarize, microservices provide a modern approach to building scalable, resilient, and flexible applications. By decomposing a monolithic system into smaller services, microservices make it easier to develop, maintain, and scale software. However, they also come with challenges in managing service communication, data consistency, and operational complexity. Thanks for watching the video.